Hey there, welcome back to my channel. Today, I'm going to break down one of the coolest concepts in machine learning, unsupervised learning, specifically clustering techniques. Sounds fancy? Don't worry, by the end of this video, you'll get the hang of it. So what exactly is unsupervised learning? Imagine you've got a heap of data, but you don't have any labels or categories to go by. Unsupervised learning is like trying to make sense of a jigsaw puzzle without having the picture on the box. It's all about finding hidden patterns or intrinsic structures in that data. Now let's zoom in on clustering techniques. Think of clustering as sorting your messy pile of Lego bricks into groups based on shape, size, or color. The goal is to group similar data points together so that the items in the same group or cluster are more similar to each other than to those in other groups. One of the most popular clustering methods is k-means clustering. Here's how it works. You start by choosing the number of clusters, let's call it key, then the algorithm randomly assigns data points to clusters and calculates the centroid or center of each cluster. The fun part? The algorithm keeps reassigning data points and recalculating centroids until everything settles into stable clusters. It's like musical chairs, but with data. Another interesting technique is hierarchical clustering. Instead of specifying the number of clusters up front, this method builds a tree of clusters. You start with each data point as its own cluster, and then pair the closest clusters together, step by step, until you have one big cluster. The result? A dendrogram, a tree-like diagram that shows the arrangement of clusters. But wait, there's more! Density-based spatial clustering of applications with noise, or dbScan, is perfect for finding clusters of varying shapes and sizes. It groups together points that are closely packed and marks points lying alone in low-density regions as outliers. This makes dbScan super handy for real-world data, which often has irregular shapes and noise. So why should you care about clustering? Well, clustering is everywhere, from market segmentation and image compression to social network analysis and even biology. It helps in making sense of large datasets, discovering hidden patterns, and driving impactful decisions. And that's a wrap. Hopefully you now have a clearer picture of unsupervised learning and clustering techniques. Hit the like button if you found this video helpful, and don't forget to subscribe for more awesome content. See you next time!